how to graph. And just a couple of things you'll need to do. So the first thing you do is you create the graph using this command. You give it some sort of name. This really isn't terribly relevant. We don't need to use that later on. And then what you're going to do is create the different kinds of curves that you're going to be plotting on there. So G curve, that's just a graphical curve. We go ahead and we specify some color, and then we give it a name that will be handy. So here I've got the X component of velocity and the Y component of velocity of some moving object. And then the only other thing you really need to do is inside your loop is plot it. And so this graph I called vel underscore x underscore graph. If I do vel underscore x underscore graph dot plot and then feed it 2 points, it will plot that point. One thing I should note is that there's a handy little shortcut if you want to get the components of a vector quantity. If you append .x, .y, or .z to a vector quantity, it will just give you that component. So what I'm doing here is I'm plotting the x component as one curve, which will be in blue, and the y component, which will be in red, for just an object in free fall. If we go ahead and we run it, the graph will be down below the window over on this side. And so we just have an object accelerating to the right. So how do we go about graphing? Here we're going to go ahead and look at the energy, in particular the specific energy of the moon. And what I did was I copied and pasted the code from before, and then I'm just going to add in some graphs. So this just creates the overall bounding box of the graph. The important thing, setting fast equal to false. What that does is it gives us a little bit nicer graph. When we mouse over this, we can see data points and whatnot. If you set that to true, it will plot a little faster, but you don't have quite as many features over on the graph. So I've got a T graph, a U graph, and an E graph for my different properties. And then inside the while loop, I needed to add in some commands to plot the energies. Let's go full screen here. And then what I'm plotting on this graph is current time along the horizontal axis, and then either the kinetic, the potential, or the total energy on the other axis. If we go ahead and run this, you can see that it's updating these values as the object is moving around in its orbit. And you can see that that total energy green in the middle is reasonably constant. One thing that's kind of interesting is this is using the Euler chromer. It's kind of interesting to go back and switch to the Euler method and see what happens. You'll see that that total energy tends to vary a lot more, and so that's an interesting aspect to this. And so we can see that the kinetic and potential energies are oscillating while this total energy is more or less constant. All right, there you have it. And you are more than welcome to go on and try the fifth activity, which is looking at Halley's Comet moving around the sun. I encourage you to do that. I haven't written up the solutions, but have at it.